Hi, I'm Paul Beckwith. I have an experiment for you to do. Get 2 glasses of, fill 2 glasses, clear glasses with ice. Put water in up to the top, and on in one of the glasses, find a thermometer and just stick the thermometer so that the bulb of the thermometer is as close to the surface as you can in the water. Okay, take a stopwatch, or just look at a clock, or use your iPhone or smartphone timer, and just start taking measurements of that temperature every minute, and plot it just on a piece of paper what the temperature is. It'll give you a hint. It's going to be 0. Okay, and just every minute record it and then get the temperature. You know what it's going to do? It's going to stay 0 till the ice is gone, and then it's going to start shooting up, and then it'll start curving over to whatever room temperature is. Take it out in the sun if you want. Okay, that's with the first glass of ice water. The second one, just drink it. Okay, you'll be, just drink it and relax and understand that you're actually doing experiment here that's very relevant to what's going to happen when we lose the sea ice in the Arctic. So what is going to happen? And by the way, this is a very good site. If you go Google Arctic sea ice graphs, or you just put in links you can put in this link and you can find the thickness, concentration, speed and drift, etc. of the ice. And have a good look at it, because this is going to be gone very, very soon. And when it is gone, if the overall trend continues, there's a high probability that the first blue ocean event, basically no sea ice, or under 1 million square kilometers, but under 1 million, I think it's just going to go to 0, essentially. If it occurs by 2020, and I demonstrated in a previous video that this is very likely, then the ice-free duration would be less than a month in September for the first blue ocean event. Maybe the ice will be gone, it's open Arctic Ocean, and then it'll start regrowing. Maybe just a couple weeks. This duration would be extended to 3 months by 2020 plus 1 or 2 years. Okay, so now it's gone August, September, October. And now you add July, and you add November. So now it's gone for about 5 months by 2023. With the feedbacks and so cascading feedbacks, one feedback like dominoes toppling, you can expect ice-free duration all year by roughly 2030 or before. So this is important because the quantity of heat that's sufficient to melt 1 kilogram of ice at just below freezing to 1 kilogram of water at just above freezing, okay, that same amount of energy would raise the temperature of that kilogram of water to 80 degrees Celsius. You can do this experiment. Take a volume of ice, a volume of ice, and put it in an equal volume of water. Boil the water if you want. Or put it into the water. Okay? If you bring the water up to 80 degrees Celsius and you put it in that water at 80 degrees Celsius, then that water will melt the ice, and the temperature of the water at the end of your experiment will be just above 0. If you take 1 kilogram of ice, for example, 1 kilogram of water at 80 degrees Celsius, put them together, you're going to end up at 0 degrees. Not 40, not 20, not 30, not 40. So the heat will be sucked out. Okay? So the ice keeps the temperature close to 0. When the ice is gone, then the temperature will greatly rise. And we know that when the temperature greatly rises in the Arctic, the jet streams will get greatly disrupted and be nothing like what they are today. Therefore, everything will be different on the planet. This is just the ice alone. I'm not, let alone what happens with Greenland. Of course, this ice melting doesn't raise the sea level, although it makes Greenland a lot warmer, and Greenland melts, and that raises the sea level. And Antarctic also is melting from below because the water is warmer, and that raises sea level as well. Okay, now as bad as this situation is with the sea ice in the Arctic, very underreported is there's another feedback that's happening twice as fast, believe it or not. You know, we're losing Arctic sea ice at 12% per decade. I actually read that on a billboard on my tornado chasing trip as we were driving through, I think it was Virginia. Okay, it was actually on a billboard. It said, do you realize that Arctic sea ice has declined 12% per decade? Is declining 12% per decade. You know, I should have stopped. I know I should have backed up on the highway, risked my life to take the picture, but, I don't know. We were chasing a storm, so we couldn't really stop. I'll have to find it on Google, or, you know, it was like a billboard at the side of the highway. It was incredible. But anyway, snow cover wasn't on the billboard. Nobody knows about snow cover, or not many people. The Northern Hemisphere snow cover is declining at about 22% per decade, as opposed to the sea ice decline of 12%. It's declining even more. So there's more and more area of the permafrost that is exposed. It used to be covered by snow. Now it's exposed in the spring. This is May anomalies, June anomalies, and July anomalies. And you can see we're losing this snow cover. With less snow cover, you get the dark tundra exposed, more solar radiation is absorbed into the ground. There's more heating of the Arctic, and that gets rid of even more snow cover and also makes the Arctic darker. As I said, it's darkening at a very fast rate. We can measure these things. This is what's happened in April's of. Okay, so there is a decline in April and continuing on this year. Maybe not, maybe a little increase here this year. But the trend is down, but it's not like the trends in, the key months are May, June, and July. May should be out shortly if it's not out already, to have a look. Just go to the Rutgers snow cover site, Google Rutgers snow cover Arctic if you want, and you'll get these numbers. You can look for yourself. Okay, so the problem is that Greenland is a huge amount of mass that's sitting on a continent up in this region, and the surface of Greenland we're getting melting on the surface. In fact, in 2012, we had tremendous amounts of melting. Almost over 90% of the area of Greenland was undergoing melting. So then you get melt pools, and then it gets a lot darker. This is what's happened in 2016. So the percentage of Greenland ice sheet with surface melting was huge. The gray is 2012. The average is the dashed blue line. Okay, so the change in melting days is also much larger here. This is a melting day change. Up to 40 days of more days of melting on Greenland as climate is rapidly changing. And that you can get this from the Arctic Report Card 2016. You can just Google it and get that. There's a lot of good stuff on the Arctic in this report. So the mass loss from Greenland is trending. It's not linear. It's trending above linear. It's trending actually exponentially down. Okay, with the doubling, a half-life or a doubling rate of about every 7 years, it's doubling. So the monthly change in total mass of gigatons, we're talking gigatons. This is huge amounts of ice. A gigaton, 1 billion tons, right? Mega, 10 to the 6, a million. Giga, 10 to the 9th. A ton, 1,000 kilograms. Kilogram, about 2.2 pounds for the American audience. I may not be saying this since, as long as the federal government is messed up. But anyway, I will. It's not your fault. Well, it might be. I mean, presumably, it could be. Could be partly your fault. Maybe it's the fault of free speech, We let organizations like Fox News spew out inaccuracies for a decade, and we wonder why the federal government is now, you know, of that view. Whatever. I'll stay out of that right now. Grace satellite, very interesting gravity anomaly satellite, and we can see the decline of Greenland ice sheet. Now the problem is, well, if we're looking, here's an interesting thing. You know, if you don't believe me, maybe you'll believe reinsurance companies. These are Munich reinsurance. Reinsurance companies insure the insurance companies. Okay, so make sure the insurance companies have insurance to offset some of their losses, and then, you know, maybe there'll be a reinsurance and a reinsurance, and then you have you know, God up at the top, I guess, or whoever can print the money anyway at the top. I guess that's the U.S. Federal Reserve. But anyway, climatology. So geophysical events, earthquakes and stuff, not a lot of change. These are meteorological events, storms, more storms now. Hydrological, more flooding, more rainfall. Climatological, more extreme temperatures. So it's getting costly, more and more costly. And that's a real poverty generator, okay? You know, if you live in Bangladesh and you don't have much and you live on a little island and a big typhoon comes in, you and a million other people have to evacuate. You know, the rivers all flood, your island gets washed away. You know, you have to repopulate on another island. You didn't own much, so you don't lose much, right? You just move and come back, start again, try to survive. You know, meanwhile, you know, in rich Western countries, you know, you get more and more flooding and more infrastructure damage, and governments start, you know, going bankrupt. They start saying, you know, they start making up stuff, and so that there's more and more dollars for military. You know, the way the U.S. is heading, eventually every dollar of taxes will go to military, and then the country collapses because there's nothing else underneath that. So there you go, from climate change. Okay, it hollows out it's a poverty generator. It puts people in poverty. You know, it wipes out stuff. Eventually it's not insured. You know, you just have to pay out of pocket. It makes people poorer and poorer and poorer. You know, and eventually at the end we're all you know, of the same wealth as people in Bangladesh. That's the way it works. Countries collapse. So anyway, that's not, you know, it'll take a bit of time, so, you know, don't worry about it. But should you save for your retirement? I don't know. So anyway, sea level is rising rapidly. The oceans are changing rapidly. The pH, the chemistry of the oceans is changing. Oceans are becoming more acidic. It's harder for shellfish to grow things. Why? CO2 in the air combines with water vapor, forms carbonic acid, it rains, acidifies the ocean. 30% more acidic than 30 to 40 years ago, because pH is a logarithmic scale. Here's the Greenland ice mass drop. Here's the Antarctic ice mass drop from Grace. The curves are 5-year doubling time red, 10 is green, it's about 7 for these. So, why is sea level rising? Water expands when it's hot, takes up more space. Mountain glaciers, that water is going into the oceans, raising it. The ice caps are melting on Greenland and Antarctica. Okay, present rise 3.4 millimeters a year. Projected 1 foot by 2050. California is saying more like 1.5 meters, even possibly you know, 4 or 6 feet by 2050. 2 meters by 2100, according to, you know, the latest numbers. James Hansen says 5 meters. I say 7 meters by 2070. There you go, 77 by 2070. In the paleo record, the rise was 50 centimeters per decade for 5 straight decades. 50 centimeters per decade, 5 centimeters per year, 2 inches per year. The oceans are capable of doing that. Will we see that in our lifetime? You know, that's going to make it very difficult to keep up with the advancing shoreline, or decreasing shoreline. Okay, so anyway, yeah, things are changing.